24 is a geometry question, right? So this kind of a ratio question, right? The ratio question, AD to DC is 1 to 2. Let's mark it. Let's mark, okay, this is 1, this is 2. Okay, and then E is a midpoint. That's a very important. So question like this, very simple diagram and just few lines with a triangle. Usually question like this can be done with mini-low theorem or mass point or something like that. But you know, this is AMC 8. Even though this number 24 is AMC 8, it's still AMC 8. And we want to make get some easier solutions, right? We don't want to involve too advanced, those kind of theorems too advanced. We don't want to do that. We want to actually find out, okay, how do we do that without going through those the fancy theorems, right? So let's see what we can do with a midpoint, right? So whenever there's a midpoint, in a triangle we could do, okay, let me draw a separate diagram. So if there's a midpoint on one side and a midpoint on the other side, we connect them, we get a parallel line. Okay, this line is parallel to the bottom. And also, if one side is midpoint and we get the parallel line to the bottom, the other side also are midpoints. Those are the results for midpoints. And for this question, also it involves the area ratios, right? So area ratios, let me draw you something that's useful. Okay, so as an example, so if this is a triangle, right? This is a triangle. And I draw from one side to the other side, one vertex to the other side, the midpoint of the other side. So in this situation, the two triangles on both sides, it doesn't matter what shape the original triangle is, two triangles on the side, then because it's midpoint at the bottom, you have these two are the same. Those are the bases. Bases are the same, and the altitude is also the same, okay? Because they have one common vertex. So draw that line to the bottom, perpendicular line to the bottom, you have the same height. So equal bases and same height, the area of the two triangles have to be the same, right? So that's one of the conclusions we could use. Another conclusion is more relevant to this problem is this. So if you actually draw a triangle, okay, let me use still the blue color, and then this time, okay, you get a fraction. You get a fraction of the bottom. So this time we don't have a midpoint. Okay, so we have two triangles, and we want to find out the ratio of these two triangles. Okay, ratio between these two triangles, the area of these two triangles. Then suppose we have a ratio here. Okay, the side ratio, the length, the length ratio, and then the ratio of the area of the triangles. So what's the relation here? If I say ABCD here, okay? So then the two triangles here also, they have the base on the same line, so the altitudes are the same. The altitudes from A to BC, this is the same. So if you want to find out the area ratio of ABD and ADC, what you need to do is just do BD over DC. Okay, so let me write it down. ABD. I use angle. I use these square brackets to represent the area. Okay, so ABD and ACD. These are the two area ratios. The ratio between the two areas. So this is equal to BD to DC. Okay, this is equal to BD to DC. So that's basically saying the area ratio equals to the base ratio. Let's go back to this question. Okay, so we know that AD to DC is 1 to 2. That means AD is 1/3 of the whole AC. So the triangle ADB, that should give us 1/3 of the whole triangle, okay, 1/3, which is equal to 360, right? No, 360 times 1/3, right, equals 120, okay, 120 in this region. Okay, so that's 120 is the area. And then we're looking for EBF, that's small part, okay, that's small part. So we have this part, but we don't know okay, we don't know the part that's ABF, okay? So that part we need to find out. And here is the midpoint is E. So we actually found out that the triangle ABE is actually equal to 60, right? Because the both part put together is 120, and then you divide in half, okay? Divide in half because midpoint, that's 60 on this side. So all we need to calculate is the area of ABF, right? So let me actually try to erase. Okay, I erased everything. So let me mark the ones we already got. So the ones we got is AD, okay, let me write it down. ABD equals 1/3 of the whole thing, 1 equals 120. Okay, and then ABE is half of that. 60. Okay, now we need to know what is ABF, right? If we get ABF, we minus ABE, then we get EBF. But that's not so easy, okay? So we know there's a midpoint. So the goal is to find another midpoint, okay? So to make segment the triangle. So let's do this. From the point D, draw a line that's parallel to AF, okay? So let's call this G. Okay, we call this G. So DG is parallel to AF. So in that case, if E is a midpoint and F is also midpoint of BG. So these two are the same. And also, we know that this is 1 to 2 ratio, okay, 1 to 2 ratio. AD to DC 1 to 2 ratio. And so FG to GC should also be 1 to 2 ratio. The F and the FG and the BF are the same. So with the whole length, BC is the 4 pieces of this, okay? So G is the midpoint of BC. And then BF is 1/4 of the whole thing, of the whole BC, okay? So let me write down BF to BC equals 1/4. Okay, so again, I want to calculate ABF. So this triangle is 1/4 of the whole triangle. So that means I'm going to write here ABF is equal to 90. Okay, ABF is 90. We already know ABE is 60. So EBF here is equal to 30. The answer is B, okay? Answer is B.